Welcome back. In this episode, we are going to learn about RAG, Retrieval Augmented Generation. So far, we have seen how we can interact with the LLMs and ask questions and get the answers based on what LLMs already trained on. But what if we want to use our own private data with LLMs? So obviously they haven't trained on our private data and they cannot answer the questions regarding our own data. So this is where one of the technique is using this RAG. So let's understand what RAG is. And before understanding RAG, we need to understand some concepts like what is embedding, what are these embedding models, and what is these vector stores. So before understanding RAG, we need to understand few concepts. So first, let's get started with those concepts. So first of all, these LLM models that we have used so far, they have trained on large amounts of data that is already available on internet. But some data, like our private company's data, might not be available, and obviously they don't know that data, and we cannot ask questions regarding that piece of data. So, how do we let these LLMs know about this so that we can interact in a natural language? So, we need to some way feed that data into LLMs or provide as some context so that they can understand and then respond in a meaningful way. But we may have a large amount of data, and how do we feed all that data? And also it is not like a textual search like earlier. We have technologies like solar elastic search where we can feed the data and we can search, but it is like a text based search where what are the query that you are asking that needs to match with the data that we have already stored. But this LLMs, we want to search based on the meaning, not the exact comparison of text. So for example, if I say I like XYZ actors, and when I ask who are my favorite actors, it should understand that okay, these are my favorite actors, and you need to answer in the right way. But those two texts may not match with each other. In the input I mentioned these are the actors I like, but in the query I might ask who are my favorite actors. They are not overlapping, they are different, but the meaning is same. So in these embeddings, what they call embeddings, this is to capture the meaning of the words. Like when we have some data and we want to feed it, so there are these models called embedding models which can take these text or images or other data and convert them into array of floating points that represents the meaning of the data, not simply the textual representation. So once we convert the data into these embeddings, we call these embeddings or vectors, and we need to store them in a persistence medium. Like the way we store relational data in SQL databases, we can store these embedding models into vector databases. Okay, once we store the data by converting them into vectors or embeddings, we store them into vector stores. Then what we can do, we can query the data, and it is like a similarity search. It is not like a text based comparison and then getting the data. It is like a similarity search. So as I mentioned in the previous example, it need not match with the exact wordings or anything like that, but it depends on the meaning. So you can store the data in vector stores, and then you can query the data using natural language which might not have the exact words matching. So that is the process. Now coming to all this, how it all fits into RAG, what we can do, like let's say we want to generate some report, but we don't have the data required for that report in LLM knowledge base. Then what we can do, we can read the data source and then convert them into embeddings and store them in a vector database. And when we ask LLMs, before that, first, whatever the user asks for, let's say I want to get the sales report for March 2025. Okay, first I go and query for that relevant data from vector stores, and I take that data and I give it to LLMs as an input and ask generate the report. LLM has the data, required data in the input prompt itself, so it is able to generate the report in whichever the desired format, maybe a markdown format or some other tabular format, something like that. So this is the whole process of RAG, where we are extending the capabilities of LLMs by feeding our own knowledge base as part of the input itself. So this is the theory part of how all this RAG works. Now let's get into the code and see how we can do this. I have created another module RAG vector store, and if you take a look at the POM file, we have ollama, but you can use other models as well. But for this example, we are using ollama. And one thing to remember, so far we have seen chart models. So we have used GPT-5 or anthropic or ollama models like llama or something like that. So these are all chart models where we can interact with the LLMs by asking questions or whatnot. But there are other models like embedding models, image models, audio models. Obviously, looking at the names, we can understand that if you want to work with audio, like you give a audio file and then you want to generate a transcription of it, you can use audio models. Similarly, you can use image models either to generate a brand new image, or you can understand what is there in that image. So you use image models for those tasks. Similarly, we can use these embedding models where we can feed some data, maybe a text data or an image or something like that, or even a video, and then we can generate floating point numbers called vectors. So these are the models we need to use for this task. So looking at this Spring AI documentation here, you can let's take a look at a few of the important points. Embeddings work by converting text, image, and video into array of floating point numbers called vectors. These vectors are designed to capture the meaning of the text, images, and videos. So it is capturing the meaning of the text by mapping those data points into some floating point numbers. Okay, so now in order to work with this RAG and doing this generating the embeddings and all, we need to use the model that supports embedding models. So if you are using OpenAI, it already supports embeddings. But if you are using, let's say, ollama, we need to pick a model. For example, if I go to ollama models, I can see here some models support tools thinking, and some models support embeddings. If you click on this, you can see what are the models that support embedding feature. Okay, so you can pick one of the model here and we can use that. For example, I have configured here I'm using ollama, and for the chat I configured the Qwen3 model, but for embeddings, I configured this Nomic embed text v1.5. So this is the model I have pulled and I configured this. So if I am using OpenAI, I can configure, okay, this is the default embedding model that is used by Spring AI. But if you want to configure other models, these are other options that are available. You can configure them as well. But for this demonstration, I'm going to use ollama with this configuration. So now we have the configuration and everything ready. Now how we can go about implementing the RAG. So first let us take some configuration here. So I have created a AI config, which is nothing but a springboot configuration class. And here I am binding these two resources that are pointing to this class path markdown files. Here in this resources data, I have two markdown files. One is about Siva, myself, and here I just have some profile details about myself, my name and what skills I have, and where did I talk about where I gave some talks, and how to reach me, like my email, blog, YouTube, so etc. All the social media contacts. So this is basically about my profile details. And this is something I have a blog post, few things I learned the hard way in 15 years of my career. So basically this is a blog post written in Markdown. So I have these two files now. And what I am going to do, once I have these two files bind to these resources, and I have configured a bean called vector store. So as I described earlier, once we convert the text into embeddings, we need to store in a database. In this case, we are going to use vector stores. As I mentioned, for storing the relational data, how we use SQL databases. Similarly, for storing these embeddings, we need a vector store. So there are a lot of vector stores available, and out of the box, Spring AI provides this simple vector store. You don't need to download or run anything. This just in-memory implementation. So this is good enough for learning purpose, but for production, obviously you need to use something more reliable. So here, let's go with this simple first, and then later we see how we can use a different vector store. So once you add this embedding support, you will get this embedding model auto configured, and you can create this vector store bean like this simple vector store dot build, and you take this embedding model and you create this bean. Okay, now once I start the application, automatically I would like to parse these files and generate the embeddings and store into this vector store. So for that, I am configuring this application runner bean, which is going to automatically execute once I start the application. So here I am injecting this vector store, and I am trying to load these two documents into this vector store. So this is nothing but another private method here. And based on the type of document you are trying to load, you can use different document readers. So Spring AI already provides document reader, writers, and all that. So here in this case, if you want to read some text file, you can go use this text reader. If you are trying to read from PDF files, you can use this PDF document reader. And if you are reading from some MS Office documents, PPTs, and all that, you can go for TCAR document reader. So basically, you can add these starters from Spring Initializer itself. So here you can see there are dedicated document readers for different formats, for Markdown, for PDFs, and for other various types of formats. So based on your type of data, you can add these starters. So I have already added them. If you go here, you can see Markdown document reader, PDF document reader, TCAR document reader. We already added these three things. So once, because I have these Markdown files, I have created a Markdown document reader, and by specifying what are the resource I am passing, and then we are passing this default configuration, and once we have a document reader, we can simply call the get method, which is going to return a list of documents. Again, this document is a type provided by Spring AI itself. So it is going to take care of parsing the document and then preparing this list of documents. Sometimes these documents may be large documents, and you may want to split them before converting them into embeddings. So this is where you can use a text splitter, and you can pass those documents, which is going to further split into more documents. And once you have all the documents, you can simply call this accept method and pass these documents, which is going to take care of internally generating the embeddings and then finally store into these vector databases. So we are automatically on the application startup itself, we are taking these two files and then generating the embeddings and storing into this vector store. Okay, now that we have the data in our vector store, how we can query them? Okay, so now let us take a look at this chart controller. And before talking about search, here are a couple of things that we can understand. I already mentioned, okay, we can generate the embeddings and all that, right? So here is some example that you can take a look at. Let's say we have this text and we want to generate embeddings. So we have embedding model configured by Spring AI. You can simply call embed and pass this text, which is going to return these embeddings, which are nothing but floating point arrays. This is how you can simply convert a piece of text into embeddings. Or if you have a list of strings, you can also pass the list of strings and then you get a list of floating point arrays as well. Or we have seen the document, right? That is nothing but we can pass some data and also pass some metadata. This is nothing but metadata. Here I am saying the source is from some uploaded documents. So you have a document. Now you can again pass that document to embed method, which is going to generate a floating point array. So these are all different. Otherwise, you can also create a embedding request by passing a list of strings, and you can pass even options. And then you can call the embedding model.call, pass the embedding request, and generate the response, which is again nothing but containing all the list of floating point arrays. So basically, this is nothing but you input data. In this case, it's just a text, but you can also pass the media like images and all, and you get the floating point arrays. Finally, once you have the floating point arrays, you can store them into vector stores. Okay. Let's say once we have all the data in our vector store, this is how you can query the data. Let's say this is another API endpoint we are using here, and we ask for some question, and we can say similarity search and pass the whatever the query that we are asking for. So what it will do, it will search for the similarity in terms of meaning in the vector store, and then return the documents that matches with this query. And once we have the documents, in this case we just want to club all of them into a text and then return it. So earlier we have seen we have loaded these two documents, right, about Siva and this one, and we have already stored that into vector database, and we have this API endpoint. Now let us see how it works. So let me start the application. So here I have a API endpoint. I'm trying to invoke this API search endpoint, and here I am asking how to contact Siva. So if you take a look at the text here, how to reach Siva, or we can even make it different, but it is kind of a meaning from the meaning point of view, they are kind of a similar, right? So let's see how what kind of response we are going to get if I ask how to contact Siva. So let me trigger this API endpoint. So here you can see it is returning the document from that markdown file that contains all the details here. Okay, so here you can see this is nothing but all the data that is there inside this file. Okay, so that is how you can query the data from vector store by using this similarity. We can pass more filter techniques and all that, but basically this is the concept. This API endpoint I have created just to see how we can behind the scenes use vector stores for querying relevant data. But our main question would be, we have this chart API endpoint where we can ask some question, and we want to ask some question about the data we have ingested already. Okay, but here if I ask, okay, how to contact Siva through this API endpoint, here we are asking LLMs, right? But we just stored the data in a vector store. But how LLM is going to use the data that is there in vector store, this is where we are going to add this advisor, question answer advisor, builder, vector store, and builder. So earlier we have seen how we can use this message chart memory advisor to automatically add the previous conversation. Similarly, there is this question and question answer advisor, which is going to take care of first query the vector store, get the relevant data, and append to the prompt that user is already asked. So for that, let us do one thing. If we go into this question answer advisor, here you can see a prompt template where a query, which is nothing but the query that is asked by the actual user. And then we have this context information is below surrounded by these markers. So this is where the relevant data that we pulled from vector store is going to be placed. And then we are saying, given the context and provide history information, blah, 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 only answer based on this context. Okay. So this is how internally it is going to work. For that, let us also take a look at, okay. So here I'm going to put a breakpoint, and in this augmented user text, we can see effectively what prompt we are sending to the LLM. So I put a breakpoint here. Let us see what value it is going to have in this. So here I'm making a call to API chat endpoint, and I'm asking how to contact Siva. So here let's trigger this API. And here we got the breakpoint. And if you take a look at this augmented text, so let's view this. So this is the query I have asked. This is the prompt I asked. But behind the scenes, this question answer advisor take care of asking, querying the vector store, and then got the relevant data. So here you can see it got all this data from vector store appended to the prompt, and then we are sending that as a prompt to the LLM. So now let it go, and now see what kind of a response we are going to get. So here you can see the response. Okay, the user is asking how to contact Siva. Let me check the context provider. Looking at the context, there is email listed as SivaLabs.in.com. Also, there are links to his blog, YouTube, LinkedIn, GitHub, all this. See all those context point. So here we have all the data that is returned. Let's try this from UI itself and see how. So in the previous episode, we have built this nice UI, and let me ask this question from UI and see how it is going to respond. So here you can see it got the data, it returned all the details for myself. So here you can understand that we are not only able to interact with the LLMs based on what it already knows. Here we are able to feed the data, our own data, and then we are able to interact with using natural language. So we are essentially extending the capabilities of these LLMs by using this RAG technique. So now we have seen how we can use this default simple vector store that is good enough for POCs and for learning purposes, but obviously we should use something more stable and persistence medium to persist all this data, right? So now let us see. If we take a look at the Spring AI documentation, there are a lot of databases that supports vector storing. So here you can see there are a lot of options, but let's see how we can use Redis. Redis we can use as a vector database. Let us see how we can configure Redis and use for RAG. As I mentioned, I would like to use Redis as a vector database. So here I can go ahead and search for Redis. Here you can see Redis search and a query vector database. So I can add this. And also I would like to use Docker Compose support for spinning up this Redis instance. So if I select that, if I explore, you can see some dependencies added. Here you can see Spring AI Starter Vector Store Redis. This is the dependency that needs to be added. And also here we have both our Springboot Docker Compose support, that is for generic Docker Compose support for any databases and things like that. So here there is one more module that is tailored for AI components. So here we have Spring AI Springboot Docker Compose. So these are the dependencies we need, and I have already added them in our POM file. So here we have vector store Redis and Docker Compose, both of them. And also, while generating this, it is going to generate this compose YAML file, and it use Redis tag as the Redis database. Because it's a different instance, we need to specify this label so that service connection feature automatically works. So we already have that in compose.yaml file. I changed the version from latest to this specific version. This is always a good practice to use a specific version instead of latest. And finally, we need to configure to initialize the schema. So as I mentioned, Spring AI supports a wide range of vector databases, including there is Postgres variation also, PG vector. So in order to store this data, we need to have some database type, right? We need to initialize it. So most of the supporting databases also allows you to automatically initialize the schema, and we can simply enable it by configuring this property. So now that we have everything, we can simply comment the previous simple vector store bean configuration. We don't need it anymore because we have added the starter, which automatically going to configure a vector store, which is nothing but backed by Redis vector store. We can even check that. Let's say put a breakpoint here, and when we start the application, we should see what type of a vector store we have here. Let me restart. So here you can see the vector store is a Redis vector store. So everything is configured using Redis now. Let me proceed. Now we can ask the same question, like let's go back and give me Siva's social media contacts. Let's see whether it is able to query the Redis vector database and pull my data and give the contact details. Yes, so here you can see details and then my social media contact details here. So that is how you can leverage one of the supporting vector databases for implementing RAG. And this is a kind of a very powerful technique. RAG is one of the approach where you can add your personal data, private data as a context, and then you will be able to interact with through LLMs using natural language prompts. So I hope you understand the concept of RAG and how to implement it with practical examples here. I hope you understand how to leverage the technique of RAG for extending the capabilities of LLMs. So thanks for watching and stay tuned for the upcoming videos. Bye bye.